The last one, you guys will have time to complete this, whereas the other classes had just enough to write down. I just try to come up with a problem where there's as many energies going on as once, because if you can do this, or really if you can do any of the other ones, then what we have on the test is much simpler than that. Ultimate energy 1. So what we have going on is at the top of this 68-meter hill, the cart is already moving. It then goes down, and then goes up. And then we have a series of things that are used to slow it down. First of all, it goes up a height here. Then it goes across a friction patch, which slows it down even further. And then it compresses all the way 4 meters into the spring to slow down. You don't have to think about this as multiple different energy transformations. Everything here is contributing to basically equal everything here on this side. So the friction patch and the spring don't have to be happening at the same time. Basically, one thing, this is slowing it down. It's going up a height. It then goes up across the friction patch and slows down even further. It's still moving and then compresses against the spring. So we're trying to figure out what is the coefficient of friction of this friction patch. But let's first just write out what type of energies or work we have in the beginning, and then set them equal to what we have at the end. It doesn't mention it there, but basically whenever I'm talking about a spring, I'm assuming that it comes to, so just add that it is not moving when it hits that spring. Because we're saying that when it compresses itself 4 meters, it's there. So going through the checklist of asking ourselves what is going on at the very beginning. Is it moving, yay or nay? Yes, kinetic energy. Is it at a height greater than 0? It is also at a height greater than 0. Could there be a spring at the beginning? Yes, it's possible for a spring to be there at the beginning. I just don't have it in this case. But there's no spring at the beginning, and there's no additional work that's being done by anything at the top. What would that maybe even look like? It could be like, well, you have somebody's pushing it over a certain distance, but there's no work due to that. So in our kind of scheme of things, that's all we have at the beginning. And so even though it's moving when it goes up the hill and across the friction patch, we're looking at all of these basically acting at the same time. That's how we can think about it energy-wise. So is it moving at the very end? It is not moving at the very end, so no kinetic energy. Is it at a height greater than 0? Yes, and this is a different gravitational, if it helps to do initial and final. There is a spring present. And we do have some work due to friction. Now, we had introduced this mu mgd on another worksheet. If we ever did have this, I would give you that equation, but basically this right here goes into that. So, like I said, I'm not giving you 30 of these to do on a test, so I'm making sure you write out. So we have definitely enough time if you want to get it done now, but the other classes had to figure that out if we could write out our equations. So, write it out blank. And if you're like, I don't want to write it out blank, well, this is my 5th time doing it, so I get that fun. And when I put that mu mg into parentheses, the force of friction is the part that is equal to mu mg. As long as it is a flat ground, then we can use that. And there's also distance. So going through what we are given the mass. We are given the initial velocity. We are given gravity. We are given the initial height. We are given gravity. We are given the final height. We are not only told what the spring constant is, but we're told how far it is compressed. We know gravity, and it also tells us here how far it goes across the friction patch. And what do you know? The only thing that we don't have is what we are trying to find. But it's very important. If you're not understanding where we're getting these energies or how to find that, then there's no way you can possibly get these problems right. If you do not have which energies we have before and after correct, then you're not even going to have the right equations, and it's going to be all around from there. So That's why it's practicing going through that checklist. Is it moving? Is it a height greater than 0? Is there a spring? Is there friction? Is there work? And then just taking your time to write it out. Because when I did it in another class, I wrote it out as many times as I had to guarantee that I could get that answer. And when you do find that, and when you do your work, your mu should come out to 0.81. You say, well, I did it all on my calculator. Great. Show that you can do it here.